On June 12, 2026, US government ordered Anthropic to shut down their large language models Mythos and Fable 5. The whole world could not reach these models for 19 days. All while the top tier cloud models prices are climbing. The obvious solution is run AI locally on your own machine. But the flagship models are so far ahead. Are they really? So the real question is, when will local AI reach today's flagship level on consumer GPUs? To answer the question, we need to compare the model, so we need to know what to test. In this case, we will concentrate on reasoning for everyday stuff and of course agentic coding, which is much harder. To find out when the local LLMs, the open weight models, will catch the cloud frontier models in the future, we have to look at the past and the gaps between the local models and the cloud frontier models. To measure the gaps, we will use benchmarks, and yes, you and me, we know benchmarks are lying. I even made a video about that. Nevertheless, for us, the order of magnitude is sufficient. So once two models are very close to each other in a benchmark, then we say, okay, the gap has been closed. For reasoning, we will use MMLU Pro, that is multiple choice exam questions, and later we have to switch to GPQA Diamond, which is much harder. For agentic coding, we have two benchmarks. Human eval was the first benchmark. Well, in fact, there was no agentic coding. There was not even LLM being capable of doing agentic coding. So human eval is just coding one Python function. Later we have SWE-bench, which is much harder, but that benchmark did not exist in the past. So again, two benchmarks here. Open weight models are huge. They have hundreds of billions of parameters, some meanwhile even more than 1,000 billions of parameters, and only a few of us own 512 to 1024 gigabytes of RAM or VRAM. So originally my plan was to compare 3 VRAM classes and their performance and how fast they closed the gap to the cloud frontier models. One with 128 gigabytes, because there is lots of hardware being planned to be released or already released, like AMD Strix Halo, NVIDIA DGX Spark, RTX Spark, Mac Minis with 128 gigabytes, and the third class, which is even more consumer level, from 16 to 32 gigabytes. These are existing PCs with consumer GPUs, 16 to 32 gigabytes. But frankly speaking, when loading an open weight model into your GPU, that's not sufficient. You additionally need some headroom for the context, the KV cache. I found that 16 GB is very limited. If you really want to catch the cloud frontier models in the future, that's easier when using 32 gigabytes. Additionally, I found that there is not much difference between the performance of the 128 gigabyte class and the 32 gigabyte class. Yes, 128 gigabytes give you more headroom for KV cache. You can use better quality quantization. So we will concentrate on the cloud flagship models, the 512 gigabytes open model class and the 32 gigabytes class. Now look at the timeline. In November 2022, ChatGPT 3.5, the ChatGPT moment, the first AI the whole world used, it started everything. In MMLU, it reached 70, human eval 48. The first open weight model which touched these values was in December 2023, Mixtral 8, 7 billion parameters, MMLU 71, but in human eval only 40. It took more than 1.5 years until we had the very famous Llama 3 with 70 billion parameters, which reached in MMLU 82 and human eval 81. So the first open weight model with ChatGPT performance. It took even longer till July 2024 for the 30 GB class. We had Qwen 2, 70 billion parameters, which reached MMLU 70 and human eval 80. With Q4 quantization around 4.5 GB that runs even on a 8 GB card. In March 2023 we had GPT-4, the first model that felt genially smart. It passed exams, it was the reference point for over a year. MMLU 86, human eval 67. It took till July 2024 when we had Llama 3.1 with the enormous number of 405 billion parameters, natively 800 gigabytes. MMLU 87, human eval 89. 2 months later we had a similar level in the 32 GB class with Qwen 2.5, 32 billion parameters and 19 gigabytes VRAM with Q4 quantization. MMLU 84, human eval 88. By the way, quantizations like Q4 have a certain impact on performance. It's usually between 2 and 8%. That's noticeably, but less than I have expected. In May 2024 there was GPT-4o, one of my favorite models I've used very often. It was fast, cheap, multimodal, have been used by millions of people. MMLU 89, human eval 90. But then there was December 2024 with DeepSeek V3, 681 billion parameters, again a very large open weight model with MMLU 88.9 and human eval in the low 80s, so not matched it completely, but it shocked the industry on costs because according to the makers it was trained for $5.6 million US. The 32 gigabytes class did not match GPT-4o regarding benchmarks, as we'll see in a moment. In September 2024 there was Qwen 2.5 with 32 billion parameters, MMLU 84, human eval 88, close but not matched it completely. In November 2024 there was Qwen 2.5 Coda with 32 billion parameters, MMLU only in the 60s, but at least human eval 92, so yes, that matched. Nevertheless, then the benchmark switched, MMLU and human eval not been used anymore, and well, we have to switch now to GPQA Diamond for reasoning and SWE-bench for code. In December 2024 there was 01, the reasoning error, thinking before answering. In GPQA 78, SWE-bench verified 49. But then again a shock, and again DeepSeek in January 2025. DeepSeek R1 with 671 billion parameters already reached GPQA 72 and SWE-bench 49. That was just very few weeks after 01 and it crashed the Nvidia stock for a day. DeepSeek R1 0528 improved even the result with GPQA 81 and SWE-bench verified 58. So the lag was only 5 to 6 months. For the 32 gigabytes class we have in January 2025 DeepSeek R1 Distill Qwen 32B with roughly 20 gigabytes in Q4 quantization, which reaches GPQA 62. So the reasoning arrived on one card, but in coding it was clearly behind. There was at that time no comparable SWE score. But in April 2026 there was already one of the community's favorite models, Qwen 3.6 27B, with 70 gigabytes in Q4 quantization, which reaches GPQA 88 and SWE-bench 77. And there's even an MOE model with 3 billion active parameters, same date, the Quinn 3.6 35B model with GPQA 86 and SWE-bench 73. Nevertheless, the dense model with 27 billion parameters is more popular in the community and can be even used with agents like Hermes and OpenClaw. So as we have seen for the giant open weight models, the gap was closing from more than 1 year to only a very few months. For the 32 gigabytes VRAM class, it's between 16 and 20 months. Now here comes the fun part, today's frontier models. Claude Opus 4.8, GPQA 93, SWE-bench verified 89. Well, Fable 5, which is already back online, with a fallback to Opus 4.8, SWE-bench verified 95 and SWE-bench Pro 80. No GPQA figure published, it's just called state of the art. According to Epoch AI, since January Open Model Trades Frontier by 4 months, but there is a caveat. With a stricter criterion, the same data gives 6 months. 4 is the friendly reading. What we have seen in our timeline, it was 1.5 years, then the gap fell to 1 year and then to a very few months. The closest open weight models are currently DeepSeek V4 Pro with the enormous number of 1600 billion parameters, which reaches GPQA 90 and SWE-bench 81. And there is currently very popular newer GLM 5.2, an MOE model with 744 billion parameters, 40 billion parameters active, which reaches on SWE-bench Pro 62 and GPQA Diamond 91.2. Remarkable, it is the first open weight model to beat GPT 5.5 on SWE-bench Pro. The 32 GB class, according to Epoch AI, the reasoning gap closes in 6 to 12 months, but they don't give any data on SWE-bench. The wider gap is coding today. Expect up to 20 months for this gap being closed. So if you're optimistic, that will happen in 2027. If you're a pessimist, then most probably in 2028. I'm currently optimistic. If you want to close this gap more earlier with more VRAM like 512 or 1024 gigabytes, you buy time, catch the online frontier models earlier. If you use a 32 gigabytes GPU or a dual mix GPU in a tower or eGPU like I covered in my videos, that just takes a bit longer. Nevertheless, according to Epoch AI, the consumer tier improves faster than frontier, so the gap closes. One point we have to be honest about, and that is why Cloud AI still might feel much smarter. They have web search, code execution, file and image analysis and generation all built in. If we had a similar toolkit in our local models, these local models might feel similarly smart. But that's not the topic of today, and I'm thinking about covering such an infrastructure in a future video if that sounds interesting for you. So which model are you using, and does it already feel flagship-like? If you enjoyed the video, please leave a like and subscribe if you want to see more content like that. My next video is about the Intel Arc A770 on Linux, the already promised performance test. Stay curious.